Nowadays, the world advances at high speed, also encounter daily information expressed in numbers. Understand them is an ability that every human has. For instance, some educators can argue that the children do not excel on math because it is hard, but sometimes some of them have a huge handicap. 7% of the world has dyscalculia, but only in the last 20 years, 12 patents to products for helping them were filed, and only 2 were granted. The density of a solution is huge. Here we propose product to level the field between them and the rest of the world.
We are proposing an integral solution consisting of 3 devices that altogether act as a personal assistant that helps fulfill common activities lost in operational dyscalculia, such as performing basic arithmetic operations and short-term number memory, doing it without significantly affecting day-to-day life or provoking discomfort. In case number 1, which is quick arithmetic calculation and data saving, the device will continually sense for speech. Once it detects the start of a conversation, it will start analyzing the data. And if it senses a triggering word such as edit, it will start recording and then send the information back into the smartphone, in which it will be downloaded, it will be processed, and then depending on the information, it can either be uploaded or sent to the wearables for appropriate notification. In case number 2, which is geolocalization triggered information displayed, the device will continuously analyze the location of the user. Once he arrives to a relevant destination, the app will retrieve relevant information related to it and send it automatically to the headphone, cell phone, and wearable, giving useful insights into what is to come for the user.
As our proof of concept, we developed a MATLAB program that performs an audio recording with predefined time duration and sample rate. We store the audio file and use it for the next input of our program. We use the Google API speech-to-text, which we re-initialize with the WAV file. This fetches us a table which we convert into an array and we evaluate the first word. There are 4 voice commands. The first one is recover, with this one, we define a GPS circle around us and we compare with the radius without storage data. If the radius is lower than our threshold, an audio and text message will be displayed with the important information of the location. Recover.
$75,156 battles of alcohol.
The next command is remember. With this command, we can store a number and the context of the number. Remember, 75 inhalers. Stop. The next command is operation. The operation command will listen the numbers and operators and perform the corresponding arithmetic operation and display a message. Operation 7 divided by 4. The last command is save. Save command is very similar as remember command, with the difference that we'll also store a message, and if the result of the save, the lab result is this.
We also have a prototype of a GPS module in Proteus, which we simulated and displayed at geolocation with defined values. Longitude and latitude data is stored and displayed in an LCD screen, and a real-time map is displayed in a virtual terminal. More work needs to be done to automate a more efficient way to manipulate the datasets and merge the 2 systems as one. In order to collect GPS data, we use the GPS sensor included in MATLAB Mobile. With this sensor, we stored latitude, longitude, and speed data from our cell phones. in a .mat file, and we further processed it in our MATLAB code.
We propose this system as it does not require specific components nor existing algorithms. Even though we propose the creation of an earphone just for this purpose, any headphone set, smartphone, and smartwatch can be used if desired. The algorithms that can be used already exist in assistants such as Amazon Alexa, iHome, and Google Home, for example. It is the purpose of these components and systems what can and will make the difference for neurodiversity.